Good morning, student. Today we will see how the energy transfer by heat or a work. So, how does energy cross a closed system boundary? Energy can cross the boundary of a closed system in two distinct forms. One is heat and work. It is important to distinguish between the two forms of energy. Huh? It is important to distinguish between the two forms of the energy. We know that from experience that a can of soda, if that the can of cold soda left on a table eventually warms up, and that a hot baked potato on the same table cools down. The transfer when a body is left in a medium that is a different temperature, energy transfer takes place between the body and surrounding medium until the thermal equilibrium is established. That is, the body and the medium reach the same temperature. The direction of energy transfer is always from the higher temperature body to the lower temperature one. Once the temperature equality is established, energy transfer stops. In the process described above, energy is said to be transferred in the form of heat. So, if the energy transfer across the boundaries of a closed system is due to temperature difference, it will be termed as heat. Otherwise, it will be work. So, what do we mean by heat? Heat is defined as the form of energy that is transferred between the two systems or a system and its surrounding by virtue of temperature difference. By virtue of temperature difference. That is, an energy interaction is heat only if it takes place because of temperature difference. Then it follows that there cannot be any heat transfer between the two systems that are at the same temperature. Now, heat is an energy in transition. It is recognized only as it crosses the boundary of the system. Consider this hot, consider this hot baked potato once more time. The potato contains energy, but this energy is heat transfer only as it passes through the skin of the potato to reach the air, as shown in this figure. Once in the surrounding, the transferred heat becomes part of the internal energy of surrounding. Thus, in thermodynamics, the term heat simply means heat transfer. Now, a process no heat transfer. That is, we will see the adiabatic process where adiabatic process means no heat transfer. So a process during which there is no heat transfer is called as an adiabatic process. The process during which there is no heat transfer is called as an adiabatic process. The word adiabatic comes from the Greek word adiabatos, which means not to be passed. Which means not to be passed. There are two ways a process can be adiabatic. Either the system is well insulated. One way is either the system is well insulated so that only a negligible amount of heat can pass through that boundary, or or both the system and the surroundings are at same temperature. Both the system and surrounding are at the same temperature, and therefore there is no driving force. If they are both system and surrounding are at same temperature, then there will be no driving force. That is the temperature difference for heat transfer. An adiabatic process should not be confused with an isothermal process. See, these are the two different processes. Adiabatic process and isothermal process are the different processes. The energy content and thus the temperature of a system can still be changed by other means such as work. Now, what are the symbols of the heat? The Q or Q12. This is the definition: the amount of total heat transferred during a process from state 1 to state 2. Its unit is kilojoule or a British thermal unit. Then small q will also a unit of heat transfer per unit mass. That is, unit is kilojoule per kg, and q dot is a rate of heat transfer. Its unit is kilojoule per second or kilowatt. Now sign convention for the heat. Now sign convention for the heat is that heat transfer to a system is always to be taken as a positive. Heat transfer to a system is always to be taken as a positive. Heat transfer from a system is always to be taken as a negative. Got it? Heat transfer to a system is always taken as a positive. Heat transfer from a system is always to be taken as a negative. Now, what do you mean by the work? Now, work is defined as the energy transfer associated with the force acting through a distance. Work is defined as the energy transfer associated with force acting through a distance, that is called work. Now symbols of work: W or W1, W12. This is the amount of work done by or on a system during process from state 1 to state 2. Its units is kilojoule or British thermal unit. Small w is nothing but the work per unit mass. Its units are kilojoule per kg or BTU per lbm. W dot is nothing but it is a unit of a power. Power is nothing but the work done by unit time, and its unit is kilojoule per second, or it is also called as a kilowatt. Now important thing about the work, its sign convention of the work. The work done on a system, the work done on a system by an external force acting in the direction of motion is to be taken as negative. The work done on a system by an external force acting in the direction of motion is to be taken as a negative. The work done by a system against an external force, I mean against an external force acting in the opposite direction of the motion is to be taken as a positive. The work done by a system against an external force acting in the opposite direction of the motion is to be taken as a positive. Now we'll see the characteristics. We'll see the characteristics of the heat and work. Now both of the them are boundary phenomena. Both work and heat are the boundary phenomena. That is, they are recognized at the boundaries of the system as they cross them. They are recognized. They are recognized at the boundaries of a system as they cross the boundaries. That is, both heat and work are boundary phenomena. Neither can be possessed by a system. System possesses energy but not heat or work. System possesses energy, not heat or work. Both are associated with a process. Both are associated with a process, not a state. Both are associated with process, not a state. Unlike properties, heat or work has no meaning at a state. Both are associated with a process, not a state. Unlike properties, heat or work has no meaning at a state. And both are path functions. Both are path functions, that is, their magnitudes depend on the path. Their magnitude depend on the path followed during a process as well as the end states. Okay, I think this is enough for today. Thank you.